Subnetting. I know, it's one of those words in networking that can make people nervous. It's usually taught with a whole bunch of complicated math. But in this explainer, we're going to do something completely different. We're going to make subnetting feel logical, intuitive, and dare I say it, simple.
So let's just start with a promise. We're not going to do a single calculation today. Not one. Instead, we're going to build the mental model, the core idea that you need before any of that math could possibly make sense. We're building the why before we ever get to the how.
So, what is subnetting really? That word itself sounds super technical, and let's be honest, it's often taught in a way that makes it seem that way. But what if I told you the main idea is something you already get without even realizing it?
And this is it. Seriously. At its heart, subnetting is just taking one big network and chopping it up into smaller, more manageable ones. It's purely an organizational tool. Think of it like taking a huge, noisy open-plan office and putting up some walls to create smaller, focused team rooms.
So the whole point, the big takeaway here, is that we're just breaking a big thing into smaller pieces. In each of those smaller networks, we just call it a subnet. Literally, a subnetwork. That's it. But okay, that leads to the obvious question. Why even bother? Why do we need to do this at all? Well, to really understand why subnetting is so critical, you have to see the absolute chaos it was designed to fix. So picture this, a big company with 1,000 computers. Now imagine if all 1,000 of those machines were all on one single gigantic flat network. It would be like trying to get your work done with all 1,000 employees shouting in the same giant auditorium. It would be impossible. So that single, massive digital room creates three enormous problems. First, you get this huge amount of broadcast traffic. Think of a broadcast like a company-wide announcement over a loudspeaker. Now imagine that happening for every little thing. It goes to every single computer, creating a ton of noise. Second, security is a total nightmare because everyone can basically see and mess with everyone else. And third, performance just tanks as the whole network gets clogged up with all that chatter.
Yeah, this kind of setup is just a recipe for chaos. It's inefficient, it's not secure, and as the company grows, it becomes completely unmanageable. It just doesn't scale.
And this is where subnetting just swoops in to save the day. We solve the chaos by doing the exact same thing we do in a real office building. We give each department its own dedicated space. Accounting gets its own little network, IT gets its own, and HR gets its own. Each of those is a subnet.
And that, right there, is subnetting in action. We've taken one huge, chaotic network and we've logically sliced it up into smaller, organized, efficient little groups. It brings order, it helps security, and it just makes everything run better.
Okay, but this brings up a new question, right? If we've put up all these digital walls between departments, how does someone in accounting send a file to someone in HR? This is where a really critical piece of networking gear comes into play, the router. And this slide really nails the difference. Talking to someone inside your own subnet is like talking to a coworker in the same room. It's direct, it's easy. But if you want to talk to someone in a different subnet, you need a router. The router is like the office receptionist. It takes your message and makes sure it gets delivered to the right department.
Now this is a really crucial point. Subnetting and routing are two sides of the same coin. You really can't have one without the other in any modern network. Subnetting basically draws the map of your entire network, and routing is what reads that map to get traffic where it actually needs to go.
Now let's be super clear about what subnetting doesn't do, because there are some common myths. It's not some magic wand. It doesn't change a device's physical hardware address. It absolutely does not replace the need for routers, and it doesn't just automatically make your network secure. It's just a very important first step in building a smart, well-structured network.
So what does it do? Well, its job is simple but totally fundamental. It defines the size of each network, like how many desks can fit in each office, and it draws a clear line in the sand that says where one network ends and the next one begins. It's the blueprint.
Okay, so without getting into any math, every single subnet has three important kinds of addresses you should know about. The network address, that's like the street name. It identifies the entire neighborhood, or subnet. The host address is like the specific house number for each computer on that street. And the broadcast address, that's like a megaphone that lets you shout a message to every single house on that street, all at once.
So let's just bring it all home. Why do we do this? We use subnetting to turn that chaotic 1,000 computer mess into something efficient, organized, and high-performing. And probably most importantly, it lets us build a network that can actually grow without falling apart.
But all of this leaves us with one final massive question. We've used subnetting to draw this beautiful map, but how does a router actually read it? How does it know where one subnet stops and the next one starts? Well, the answer is something called a subnet mask, and it's the key that unlocks all the math behind this stuff. But for right now, the most important thing to remember is this. Subnetting isn't really about math. It's about bringing order to chaos. And that simple idea is what makes the entire internet possible. We'll get into that subnet mask in our next explainer.